In this video, we'll talk about the inverse of a function. So as we've done before, we'll develop an intuition for what the inverse of a function means. Then we'll go through an inverse function definition and a rather novel inverse function property. So first consider we have a function f with domain A and range B. Domain A has a collection of x values, x1, x2, and x3, and the range B has a collection of y values, y1, y2, and y3. Now, if I grab one of these x values and give them to f, I should get one of the y values, right? So if I say f of x1 equals y1, that should make sense. And if I'd say f of x3 equals y3, that should make sense, right? The inverse of a function helps us get back from the range back to the domain. That is, f inverse, typically written as f negative 1 like that, that's read as f inverse, takes things from the range and gives out something in the domain of f. So what this means is I could say f inverse of y3 should give us x3. So any number in the range of f that I hand to f inverse gives us an x value corresponding to the y value that we had in the range of f. That is, it helps us go backwards from the range back to the domain. Now suppose that I have an x4 in the domain A. Let's also say that x2 equals x4, and f of x2 equals y2, and f of x4 equals y2. If I'm trying to use f inverse of y2 to get back to the domain, it's ambiguous whether I'm going to get out x2 or x4. So we need these functions to be one-to-one. For every y value, we need to have exactly one x value. So the definition of the inverse of a function. Let f be a one-to-one function with domain A and range B. Then its inverse function, f inverse, has domain B and range A, and is defined by f inverse of y equals x if and only if f of x equals y for all y in B. It's important to note in this case that f, quote, to the negative 1 of x does not imply 1 over f of x. This is read as f inverse of x and does not mean 1 over f of x. So again, the inverse just helps us get back to the domain from some value in the range. And to be able to do that, we need mathematically for there to be only one y value for every x value. So then it should make sense that if f is a one-to-one function with domain A, range B, and inverse f inverse, and we have some little a in the domain big A, so f of a equals little b in the range B, that we could say f inverse of b should equal a, right? In other words, f inverse of f of a equals a. Since b equals f of a, if I plug f of a into f inverse, I should just get a back out. And this is a novel property of inverse functions. Let f be a one-to-one function with domain A and range B. The inverse function f inverse satisfies the following cancellation properties. F inverse of f of x equals x for all x in the domain A, and f of f inverse of x equals x for all x in B. Conversely, any function f inverse that satisfies these equations is the inverse of f.